Welcome to my hometown. My name is Mike Soskil, and I am a 3rd through 5th grade science teacher right here at the South Elementary School in the Wallenpaupack Pike Area School District in Newfoundland, Pennsylvania. I believe that the solution to every problem in the world is trapped inside the passions of our students, and that my job as a teacher is to help students understand how the learning that they do in and outside of school can be used to unlock the solutions. We're blessed here to have developed a culture of service. My students understand how powerful they are when they use their learning in real, meaningful ways in the world. These students here have done everything from clean the oceans by eliminating plastic pollution, to saving seabirds and adopting penguins in South Africa, raising money to build a bridge in rural Western Kenya that allowed more students to go to school, raising money for water filters that saved children's lives in the Kibera slum, teaching through short video using the materials that we have here in our school that other children around the world didn't have. And one of the projects that's going on just on the other side of this school right now is a gardening project in which students are growing produce and selling some of the plants and using some of the food that they've grown to donate to the local food pantry. It becomes cyclical, it becomes a snowball effect where kids understand just how good it feels to do good in the world, and they want to use their learning to do more of it. And they now continually look for ways to make the world a better place. That makes me very proud, and it's one of the reasons why I love teaching here. We do have economic problems in this community. 6 or 7 businesses have closed on Main Street recently. About 60% of our students are on free and reduced lunch and live below the poverty line. And so sometimes kids come to our school lacking hope. The projects that they do and the work that they've done in school allow them to have hope to go forward. They understand just how powerful they can be and how much they matter. And that's important because all of us want to know that we matter. The lesson you're going to see in a little while is one of my 5th grade classrooms. It's an inclusion model classroom where 8 of the 19 students are special education students. They're going to be doing a lesson called pasta mining where they're learning about renewable and non-renewable resources. I'm hoping that through the connections that we make after this lesson, that they're going to look for ways to solve some other problems in the world that they are exposed to. I hope you enjoy. Welcome to my science lab. The pasta mining lesson that you're going to see in just a minute is a lesson designed to teach renewable and non-renewable resources to students. It's a great way to model what actually happens in the natural world so that they can really understand the concepts behind resources that are able to be used again and again, and resources that take millions of years to develop, and once we use them, they're gone. This lesson came up at this time of year for several different reasons. First of all, it just so happens that our 5th graders are studying graphing in math class. And so this is a great tie-in. Too often we teach subjects in school out of context, and science and math naturally go together. Mathematics is the language of science. So this gives me an opportunity to bring what they're learning in math class into science so that it means more to them, so that they understand the context in which we're using those visual representations of data for. In addition, this is an extension of something that kids are really interested in. And that's important because we know that students have to have an emotional connection with their content in order to retain it and learn it long term. So in this case, we had been learning previously about plate tectonics and geology, and students had learned that volcanic activity in Siberia had ignited coal beds, and over hundreds of thousands of years, millions of years, those coal beds burned and put unprecedented amounts of carbon into the atmosphere. And at that time, millions of years ago, that caused a mass extinction on Earth, where 90% of the Earth's species died. So with all of the talk about us putting carbon dioxide into the atmosphere now and burning fossil fuels, children were really curious about how much of those fossil fuels were still left in the Earth, and what kind of levels we're putting, what kind of carbon dioxide emissions are we putting into the atmosphere, and could that happen again? So this is going to kick off our studies of that. As we start talking about those non-renewable resources and fossil fuels that are in the ground, we're going to be looking at some climate change data from NASA in the future. In addition, we've partnered with a group of 4th graders in Moscow, in Russia, who are going to share some of their climate data with us so we can see if there's any similarities. It gives us another opportunity to analyze data. When my students walk into my classroom, I want them to be scientists. I don't want them to just be learning science out of a textbook. And so you're going to see a lot of this lesson as hands-on. But in addition, we're going to be doing something real with the information that we're learning. And the exchange that we're going to have with Russian students is going to not only give my students a broader perspective and a worldview and a contextual reason for why we're studying what we're studying, but it's also going to let them see beyond our town, which is so important because we're in a rural, rather undiverse area of northeastern Pennsylvania. Within the lesson, during the short clip that you're going to see me use some formative assessment strategies. I'm a big believer in formative assessment. I think that my job as a teacher is to make sure that every one of my students knows what they're supposed to know during the lesson.
We got 107.
Whoa, not a competition between you guys, right? Let's get your data up on the table. Number 4s, get ready to mine. 4s, let's go.
I can't believe I collected 100.
You guys have your number?
It's just us. Oh God.
4 should be at the mine. Everyone else should be sitting quietly.
Move your pants. Dude, we went from 4973 down. Hey, that's fine.
Okay.
Feel with your hands.
Before our number 4s go, all eyes right here, please. Make sure the data is in your tables.
Come on, Austin.
Take a look at this. Okay. Daniel. Take a look at our trends here. Coal, you predicted, would continually decrease as we took more out, right? We went from 87 to 76 to 65. Is that following the trend that you expect?
Yeah.
Sure. You predicted it would decrease. It's decreasing. Solar, you predicted would stay the same. Started at 70, then it went down to 54, then went up to 107. Is this realistic for a solar plant? That some days it may not get a lot of solar power, but other days it may get a lot of solar power.
Yeah.
Could that happen in real life?
Yeah.
Sure. What would be the factor that would determine that? How many clouds there are, right? Or the length of day, depending on the time of year. Sure. So that could be realistic. Wind. Are some days windier than others?
Yeah.
Sure. Here, we seem pretty consistent though. Okay, it's about the same. This is the one that I'm curious about. We expected oil to decrease because as we take it out, there would be less and less of it. Yet look at what's happened. We went from 49 to 73 to 100. I'm curious as to why. Oil group, don't tell me your answer yet, but do you have a reason to explain this?
Yeah.
The rest of the groups, as number 4s are going, I want you to think what their reason could be. How could that have happened that even though there's less and less oil in the pile, they're getting more and more oil out? And I wonder if that trend will continue. All right, number 4s, are you ready? On your mark, get set. Not yet. Still not yet.
Oh my God.
Go.
Come on.
All right, so the rest of you, are you thinking about what to make that oil? Maybe. Could there be another? Think about a real oil.
I can't believe it. Jackie got like $1 million. Well, yeah, probably $1 million now or 200. Do we not have any? I think we have 200 at least in this pile. What are you doing?
I'm going to try and move it over so Austin has
All right. Oh, yeah, pick those up, be careful. You guys are the wind group. Can you think of why that oil is defying what we expected? What do you think, Dustin? Why do you think that's happening? But if they keep taking it out, why would they be getting more?
Because we get the
Wait, you guys want something?
because the tree can't going on top and the sun can't coming down.
So maybe we're removing the other things that are preventing us from seeing the oil. Okay. 20 seconds, by the way. seconds. Hold on a second.
We're at number 4.
5, 4, 3, 2, 1. Time's up. All right, bring those back, count them up. So Nakai, tell me. What do you think? So you find a new location. All right, you're going to explain this to us today.
Austin, that's all you got?
No.
We only count both.
Sure you're hiding nothing else.
Me and Nakai did. We probably went from 100 down to
If you guys look
80 or 60.
look in the corners and then go into the middle. There's a lot. 60 horses, so that would mean 160.
Decreased by 1.
Oh, wait, I know.
No, you're
Okay.
not.
Okay, do you have your number?
I was at 100. How many did you get?
Okay, solar power. Do you guys have your number?
106.
All right, write it down. Write it down. Put it in the table. Sam, it looks like you're missing some data from the other group.
Oh, yeah, I am. Dang it.
I'm writing it. 176. No.
Oh my god.
Increased by 1.
It is.
And we have one more to go.
Okay, you got 80? All right. Put that wind back into our natural resource box. All right, number 5s. Last minors.
Wait. Just write my data for you, okay?
Waiting on the coal group. You guys have a number?
Go right when you say don't move it. Yeah, now you have to.
Okay. All eyes right here before we go any further. Nakai, are you mining? Have a seat. Brady, you mining? Sit down, eyes here.
Go for it right there.
I have a lot of people still standing and a lot of people whose eyes are not on me. So, coal, the trend seems to have changed a little bit. Solar, wind, okay. Wind jumped up a little bit. It's the oil that really has me intrigued. So oil, we expected to decrease, yet it went down, or it went up, and kept going up, and now it started dropping off. Some of the groups, I walked around and I asked you what your prediction, or what your hypothesis was of why that was happening, right? Why did you think that was happening? And you told me maybe the oil is easier to find, so as the other things get removed, it's easier to pull out of the ground. One thing that I really liked that I heard, and I think it was from over this group over here, maybe this Sierra, I'm not sure, told me maybe they found new places. Like they took the oil out of the ground, but then they found another place where there was lots of oil and they started taking it there, right? And that's kind of what Nakai told me when I asked him. He said, we decided that after we pulled some out, that there was lots of oil around the edges. So if we just focused around the edges, we could pull it out, right? We kept finding new locations. But apparently those new locations ran out a little bit, didn't they? So I'm curious to see what the trend is going to be, or what we're going to see when number 5s go. So number 5s, are you ready? Cool, have a seat. On your mark. A lot of pressure, especially those of you that are going for the second time, right? Okay, you got to beat your first number, or try any. It's going to be tougher because some of you that their resources are out of there. On your mark. Get set. On your mark, get set. Go. Ethan, have a seat. All right, make sure you have all of the data from all of the groups. You only have all, you need all the other groups in there. Make sure you have all the data from all the groups. How the data table's looking here? That's kind of sloppy and hard to see. I would rewrite that and make it neater. That looks good. 1 minute. All right, yeah, even though, all right, like, we even that out. Okay. 35 seconds.
I just want to make that. Clean all of that. My coin, my candle.
Ten. 5. And time's up. Hands off. Take them back. Count them up.
Yes, I knew. See, Kenny, this is what it was.
Ethan.
Okay.
Get counting.
2.
I'll count you.
24.
26. Alright, so I've got 26. Yeah. 26. Did anyone get 24?
I got 24.
So that's 50. What did you get?
I got 36.
So that would be
I mean, you do have
83. No, 86.
You're doing something else.
And then 22? No, 28.
You're doing something
Oh,
else.
okay, so that would be 82. You got 38. Yeah, we have like 58. Yes. 110. I'll mark it. No, I got it. I get to mark it. I've never marked it.
You have your number counted? You guys have counted?
110. Full and was bad.
Well, because come on, 100.
No. At least 100.
68. 7.
You have your number?
75.
Okay, push him.
And then we have more over here. I'll take that.
91.
That looks like the write it on there.
Okay. All right, everybody have a seat so we can discuss the data.
That's 68 or 65.
Make sure your data table is complete, and then eyes on me, pencils down, so I know you're ready to go. Eyes ready. Did you like it? Did you have fun?
Yeah.
So I used to do this with my math class as a graphing activity, but I love the way it ties into natural resources so well for science class. So, take a look. Your prediction for coal was that it would decrease. Were you correct? 87, 76, 65, 76, 91. It ended with more coal coming out of the ground than you started. Okay. Is that what you predicted? No, you told me it was going to decrease and we would get less. Now, do you think that if we kept doing this activity for a lot longer, that that coal would have decreased? Eventually, there'd be no more coal, right? It would have to. Okay. But we didn't get to that point. There was still plenty of coal left in the ground for us to keep it. Solar power. We predicted it would stay the same. And in the beginning, it didn't. But then we're pretty consistent here, aren't we? Yeah. Once that solar power group found their groove and figured out the best way of mining, or the best way of gathering solar power, they were pretty consistent there. Wind. 65, 57, 58, 68, all kind of the same. We had one outlier, one spike up to 81. Maybe it was a really windy day. Right? And oil was the one that was kind of tricky. Right? Didn't do what we expected it to do. We started at 49, went up to 73, then we spiked at 100, and then we stayed 72, 75, right? Pretty consistent there. And we talked about some reasons why that could be. Now, looking at those numbers, it's kind of not easy to make sense of them or compare them, is it? It would be much better if we had a visual representation of this data, right? As scientists, that's what we do, right? After we gather our data, we put it in ways that it makes sense to us, and we sometimes represent it visually. How could we represent this data visually? How could we create this into something that we could look at, and it would make sense to us, and it show the data, show when it's high, show when it's low, show the trends? How could we organize it into something that we could visually look at that would explain it to us? Or explain it to other people that weren't here when we were mining our pasta? Take 30 seconds, talk in your group, come up with an answer that you all agree on. What are some ways that we could visually represent this? Go ahead. Oh.
Like the first day, it goes like day 1, 70, and then day 2, 54.
So what do you think, guys? Why a line graph instead of other graphs? Well, discuss that. Discuss that, yeah. Okay. I like how you're thinking. What'd you guys decide? Did you discuss why a line graph?
Yeah, because then it can show the decrease of the life
Those days of the days, like day 1 and
Did you discuss other kinds of graphs too?
No, I said pi.
Well, you get to numbers with percentages.
Okay. How about this group? Did you come up with something you all agreed on? How are we going to visually represent this? What do you think? Hold on, Brittany, what do you think? What did you all decide? Okay, this group needs to get together and discuss, because I hear this side being like, yeah, we got an answer on this side.
That was Michaela.
Get together and discuss, go ahead. Okay. Move over if you have to.
I don't know.
What we come up with? How are we going to visually represent it? What kind of picture? Is that going to explain the data to me? What I want is not a nice like artistic piece. What I'm looking for is how could we represent this data? What do you call it when we visually represent it? You're at a crossroads right now. You're trying to decide what it is you want to do. I remember that time well. I remember trying to choose what I wanted my life to mean, and how I was going to choose a profession that allowed me to achieve that. Before we go any further, I want you to take a second. Imagine that you're at the end of your career, and you're looking back, and you're trying to figure out whether or not you were successful. What is it that you want to have happened that would have determined that success for you? I thought about that question a lot when I was trying to choose what I wanted to do. For me, it very much had to do with, did I do something that left the world just a little bit of a better place than it was before? All of us want to matter. All of us want to know that what we're doing is meaningful. Being a teacher allows me to feel that every day. When I come into school and I work with my students and I help them realize what they're passionate about and how powerful they can be when they use their learning to solve real problems in the world, I get to feel that joy that comes from knowing that I'm doing something important. I think everyone wants that.
I happen to teach in a small town in northeastern Pennsylvania. We have economic problems here, and sometimes that manifests itself in the classroom. My students sometimes bring that baggage with them to school. Sometimes they're lacking hope. I truly believe, and I've seen in my students, that when that spark comes on, when they realize just how powerful they can be, when they help others with their learning, they have the hope that they need to go forward. I want to share one of the most powerful moments of my teaching career. My students had been working with kids in the Kibera slum of Nairobi for several months. We had been doing a math project. My students, after a cultural exchange, realized that kids in the Kibera slum don't have the same math materials that we have here in school. And so they said, we want to do something to help them. We want to share our math materials. And they started teaching through short videos, math concepts using those materials. But in exchange, they wanted the Kenyan kids to know how much they mattered as well. And so they asked the Kenyan children to teach us Swahili through video. And that exchange went on for several months. But over time, my kids realized that the lack of school supplies was not the most pressing issue facing the kids in the Kibera slum. You see, Kibera is an area of about 10 square miles, and about 1.5 million people live in that area. The infrastructure is terrible. During the rainy season, the pit toilets overflow, and sometimes the water supply gets contaminated. And once my students realized this, they instantly said to me, Mr. Soskil, we need to do something to help them. Because we had developed a culture of service in our school. Kids knew that learning was not just to pass tests and quizzes, but that learning was to be used to make the world better and to solve real problems. And so we partnered with kids in Greece and in Kansas to raise money for water filters. I happened to write a grant to fly over to Kenya to deliver math materials, to document the learning gains from our math project, but also to hand deliver those water filters. And the most powerful day of my teaching career was the day where the filters got delivered and I was able to set up a 7-school Skype call. The 5 schools that had raised money for the water filters, including my students, and the 2 schools that received them all got to meet each other and share their stories. Lots of tears were flowing, as you can imagine. For the kids in Kenya, they were hugging their filters and tears were streaming down their face because for them, those water filters might very well have saved their lives and the lives of their family members. But what was so powerful for me was seeing what was happening on the other end of that screen. I saw tears in my students' eyes as well. They were feeling the joy that comes from doing good for others. I knew instantly at that time that for the rest of their lives, they would continue to seek new ways to learn and to use that learning to do good. That's what teaching should be about. That's what learning should be about. That's the power of creating that kind of environment in a classroom. And that's the power that all of you can have. When you think about what you want to do with your life, and you think about how you can do something meaningful, teaching is where it's at. There is no more important job. Every other job in the world is created because someone taught people how to solve problems, how to do that job. Teaching is the job that creates all others. I am so thankful that I realized that early on and that I chose teaching as a profession. And I hope that you do too.